All right, so this is triangle angle theorems. So the first one is pretty simple. Triangle angle sum theorem. You guys know this. All the angles in a triangle will add up to 180 degrees. The one that you might not know is the exterior angle theorem. So what the exterior angle theorem says, if you have any angle that is created by extending a side, so in other words, this side right here is just extended straight on. If you have an exterior angle created by that, that is equal to adding the other two interiors angles together. So that will be the measure of angle 2 plus the measure of angle 3 will equal the measure of angle 1. So why this works, if I give you a little example, you know that if I gave you this would be 120, then that would obviously have to be 60 degrees because that's a straight line, 180 degrees. So if there's 60 degrees of that 180 in the triangle already taken up, if you subtract it, the other two have to add up to 120 degrees. We don't have to know exactly what they are, but we know that they add up to 120 degrees. If that's 60, there's only 120 left. So 2 and 3 will equal that exterior angle. So that's kind of where we get that from. All right, so for number 1, this one is just triangle sum theorem. 24 plus 37, you'd add those together, subtract it from 180. That will give you 119 degrees. For number 2, we don't know what that angle is there, but we don't need to know it because we have the exterior angle theorem. So that would say that angle 1 and 76 and 52, we would just add those together. That gives you 128. We don't even need to know the other one. Obviously, we could find it, but for this problem, they didn't ask for it. You can also use that and flip it around and say that this exterior angle minus one of the interior angles will give you the other one. So we'll take 104 and subtract 79, and that will give us 25 degrees. So from there, number 4, number 1, or angle 1, is pretty much just triangle angle theorem, 66 plus 84. Subtract that from 180, that will give you 30 degrees. Angle 2, well, let's find angle 3 first. So first off, 84 and angle 3 right here are just a straight line, right? So 84 and angle 3 would have to be 96. And then for angle 2, you can do the exterior angle theorem, or you could also, if we already found this 96, you could just do the 180. But there's multiple different ways that you can do it. As long as you get to the right answer, you're fine. I do want you to see with the exterior angle theorem that we could take 84 and subtract 43 from it, and that will give you angle 2, and that will be 41 degrees. For number 6, we have 61 degrees and angle 2 are vertical angles. We know that vertical angles are congruent. And then if we have a right triangle over here, and 2 is 61, well, we know that in a right triangle, this is 90 degrees. So that means that these other two angles have to add up to 90 degrees because 180 minus 90 gives you 90 remaining. So instead of doing 90 plus 61 subtract from 180, a lot of times I like to just do 90 minus 61, keep it a little more simple, and that is angle 3, and that will be 29 degrees. Then from there, angle 1 up top, 61 plus 68 subtract from 180, that will give you 51 degrees. All right, for number 7. So first off, the information it gives us is that BC bisects the angle ACD. So this line bisects ACD, which means that angle 2 and angle 3 are congruent. Now we also have a right angle down here. So that means that we can just take that 9 degrees, split it in half, and we know that angle 2 and angle 3 are 45 degrees. Then from there, we'll just do triangle angle sum theorem for both of these. So the measure of angle 1, when you add 48 and 45, we'll have 87 left over. And then the measure of angle 4, when you add 45 and 83, will give you 52 left over. All right, so these continue to get a little bit more difficult. I'll go through some, not all of them with you. I will say for number 8 that understand that 1, 2, and 90 make a straight line. So there's your little hint there. I do want to go over number 9 with you. It says that L is parallel to M. So we know that these two lines are parallel. This is really big for the parallel lines and transversals, which we just used. Because if you look at it, and I can kind of extend this line on if I need to, that is a transversal that I just drew across. So we could say that 49 and 4 are alternate interior angles, right? They're on either side of that transversal, and they're both inside. Also, we could say that angle 5 and then the sum of angle 1 and 2 are congruent. So if you look at that, if you want me to trace it out, maybe it'll help. You see how these two are obtuse, right? So those would also be congruent. There's a bunch of different ways you can do this, and that's not even the only one that we have. We do have another transversal right here, and we could look at this as well, right? And we could say that angle 3 right here, and then angle 2 and 49 added together would equal angle 3, right? Those are alternate interior angles. You could also say that angle 3 and angle 1 are consecutive interior, as well as 73, angle 2 and 49 are consecutive interior. So I want you to understand that there are plenty of different ways to solve this. I'm going to solve it in one way. Honestly, I don't even know. I can't tell you exactly how I'll do it right now. I'm just going to look at it and kind of go for it. But understand that just because I do it one way does not mean that you have to do it this way. There's plenty of other ways to see it. So, first off, I see that 3 and 73 are a straight line. So if I subtract 180 from 73, that would give me 107 as my degrees there. So then from there, if that's 107, the measure of angle 3, then I could say that angle 3 and angle 1 are consecutive interior angles. In other words, they're same side interior angles. So that means that 180 minus 107, or these two angles would add to 180. So 180 minus 107 will give us angle 1, which is 73 degrees. And some of you are like, dude, that's just alternate interior. Yes, I agree. But I'm trying to make sure that I get to everything. So I did consecutive interior. I did a linear pair there. I'm trying to just make sure I cover all of them. So then it's kind of obvious from here, 73 degrees, angle 2, and 49 would all add up to 180. So you add up 73 and 49 and subtract that from 180, and that will give you 58 degrees. So angle 2 is 58. Then from there, there's multiple ways that we could do this, but kind of the obvious one is 58 and 73 degrees. And angle 4, when you add all those up, they should equal 180 degrees, right? Because there's a triangle right here in the middle of everything. So 58 plus 73, and subtract that from 180, will be 49 degrees. And then lastly, if this is 49 degrees, you could just subtract that from 180. 49 subtracted from 180 will give us angle 5, and that's 131 degrees. So you see there's plenty of different ways to do this, right? So 49 and 49 are alternate interior angles. 131 and the sum of 73 and 58, those are alternate interior angles. They work. 107 and the sum of 49 and 58, that is 107. There's other alternate interior angles. So there's plenty of different ways that you can do this. So don't feel like there's just one specific way. Let's see here. 10, since it has a right angle, should be a little easier. I'll do 11 with you since it's a little more difficult. Bear with me and don't judge me if I mess up or make a mistake. So, we won't. We'll see. If I do, it's no big deal. So these are parallel lines. That's what that little arrow means. These are parallel lines. So now we have transversals and two parallel lines right there. So I'm just going to focus on that to start out with. First, angle 2 is 71. It's kind of easy to see. And then we know 3 and 5 will be congruent, and that would be just 180 minus 71, which would be 109. So 3 and 5 are 109. I'll kind of try and make this a little easier for you to see. Angle 1 and then 47 and 71, when you add all those up together and subtract them from 180, that will be 62 degrees. And then I know that angle 1 is alternate interior with angle 8. Right? Is that right? Should be. Yeah. That's right. Angle 1, if we said that that's 62, it's alternate interior with 8. So then 8 would be 62 degrees. So then from there, oh, okay, I see. I was wondering, I got a little confused for a second because I was like, well, if that's the case, why don't 42 and 36, why don't they equal each other? But if you notice, this angle would have to be here. Those angles would equal each other. But if you notice, that 36 is only a portion of it, that 42 is only a portion of it. So don't just automatically assume that it does. If I bold my transversals, let me make it in red. So there's my line, there's the intersection I'm looking at, and here's the other intersection I'm looking at. You can see that the 62s are the same, but the 36 and 42, they don't encompass the whole angle. So that might be a place where you guys get stumped a little bit because I just kind of looked at it a little weird. But that's okay. So then from here, we have two angles for all of the others. For angle 4, 36 and 109, add those together, subtract from 180, that will be 35. And you can do the same thing for 6, 42, 109, subtract that from 180, it'll be 29. And lastly for 7, 71, 62, add those together, subtract from 180. All right, so that's a little difficult one, but not too bad. It's kind of like a puzzle. There's a bunch of different ways to solve it. You just kind of got to figure it out. So with number 12, we will add up all three sides. That pretty much just gives you 180, which is really easy to see. I'll let you do that. X will equal 8. I'll let you plug it back in and not bore you to death just watching me solve a problem. For number 14, same thing. So this is exterior angle theorem. We know that this exterior angle is equal to the sum of these two angles. So 13x minus 11 plus 4x plus 1 will equal 18x minus 15. For there, your answer for 14 for x will be 5. And I'll kind of let you go from there. So 13 and 15 are just like 12 and 14. Pretty simple. And I'm pretty sure that's all I assigned you for the day. Let me double check real quick. And if it is, you can just leave. But I want to make sure just in case I'm not missing something. Triangle sum, exterior angle. And then the homework. Yes, awesome. That is it for today. So if you got any questions, feel free to shoot me an email